Hello and welcome back to Database Design Made Easy. It is time for part 10, where we will cover optimal normal form. An optimal normal form is in the world of normalization a rather odd beast, because as far as I know it lacks any solid academic foundation and I haven't been able to find any formal description of what it officially is. All the information about optimal normal form can be found in documentation and books about the so-called fact-based information analysis methods. Those are methods such as natural language information analysis method, object role modeling, and fully communication-oriented information modeling. Those methods then describe optimal normal form in terms of what they call elementary fact types. And we will cover what fact types and what elementary fact types are in the rest of this video. But to make matters even more complex, even within the documentation of these methods, there isn't a lot of clarity on what optimal normal form exactly is, because there are actually two different interpretations. One interpretation basically says create one table for each elementary fact type, and the other interpretation then says no, you should then combine elementary fact types that have the same key. Again, we'll cover the differences between the two and talk a bit about both of them. Let's start with the first, one table per elementary fact type. Now, if we want to talk about this interpretation of optimal normal form, then, of course, we have to understand what a fact type is. So, the whole basic idea of these fact-based information analysis methods is and goes back to the understanding that all information we ever deal with are essentially facts, and facts can be worded as sentences in English or in whatever language you want to. And of course, I have touched on that realization a few times already in the past videos. But for these information analysis methods, the very core of their approach is that information equates to facts, and they base their entire method on analyzing facts. So they don't look at tables, they don't look at columns, they look at facts such as session dev 201 by Hugo Cornelis takes place in room 205. This is information. This is a fact. But then there also might be a fact that looks similar, such as session DBA 311 by Kendra Large takes place in the Grand Ballroom. Now, when you look at those two facts, you will see that they are quite similar. There's a lot of words the same, the order of those words are the same, only the specific session, the specific name of a presenter, and the specific room are different. So within those methods, similar facts are then grouped and considered a fact type. So those two facts you see on the screen are both examples, instances of facts of the type session by presenter takes place in room. And when you look at the universe of discourse, you will find this fact type, but you will also find other fact types to represent facts that don't fit in this pattern, such as room seats up to capacity people, or presenter lives in country. So now we know what fact types are, but then what makes a fact type elementary? And don't confuse this with the term elementary from elementary key normal form. It's the same word, but it has a completely different meaning here. So when is a fact type elementary? So let's start with when is a fact type not elementary. A fact type is not elementary if you can split those facts without losing information. So let's return to the example we just had. Session by presenter takes place in room. I can split this. I can make two sentences. Session is presented by presenter and session takes place in room. And here I use the generic fact type. I can do the same with the instances. DBA 311 is presented by Canva Large. DBA 311 takes place in the Grand Ballroom. That's the same information as DBA 311 by Canva Large takes place in the Grand Ballroom. So in this case, the non-elementary fact session by presenter takes place in room can be split into two new facts without information loss. On the other hand, if a fact type cannot be split without information loss, then that is an elementary fact type. So, for example, on day you can ask expert questions about topic. You may recall this example from the videos on 4th and 5th normal form, where we found out that whether or not this fact type can be split actually depends on the universe of discourse. If Hugo is allowed to be picky, if Hugo is allowed to refuse talking about normalization on Mondays, then you cannot split on day you can ask experts question about topic in on expert is available on day and expert knows about topic, because then Hugo is available on Monday, Hugo knows about normalization, but we lost the fact that Hugo does not want to talk about normalization on Mondays. So you can't split this, and here is an example of a fact that is already elementary. Now, like I said, in optimal normal form, you create a table for each elementary fact type. So we have identified one fact type that is not elementary, split it into two new fact types that are elementary, and we identified another fact type that is elementary, and now we have these three tables. This would be optimal normal form. Now, if you look at this and think about this, you might come to the realization that this looks very similar to 6th normal form. And in fact, it is similar to 6th normal form, except when columns somehow are tied together. And that is not a very formal way to say it. So let's give you an example to clarify what I mean. So one of the fact types we had and one of the tables we had was session is presented by presenter, resulting in the table you see on the bottom left. Of course, in this universe of discourse, there will also be other fact types, such as a fact type of who all our presenters are. And then, obviously, when you implement this in your database, you will have a foreign key constraint that sessions can only be presented by presenters that are in our table of presenters. So far, so good. And then we found out when we talked about 6th normal form that we get into problems if the universe of discourse changes. If for whatever reason we need the first name and the last name to be separate columns just to satisfy 1st normal form already, then we get this design. And here is where 6th normal form and optimal normal form change. In 6th normal form, we would have had we would have had an extra table. We would have a table with session and first name, and another table with session and last name, because there is a join dependency here, implied by the key, but it's there. In optimal normal form, this tied together now kicks in. First name and last name together are a unit, and that unit represents a presenter. So we keep them together in the optimal normal form presentation, which means that we still can implement a foreign key that prevents us from scheduling sessions by people who aren't even on our presenter list. Now, this very nicely avoids the 6th normal form problems with composite keys, alternate keys and foreign keys. So we avoid those problems while still having this so-called benefit. Again, I don't see the benefit, but still having this so-called benefit of not having null values in stored data. So optimal normal form shares that perceived benefit that we don't store nulls, while avoiding the weaknesses of sixth normal form that occur when you have composite, alternate or foreign keys. However, just as official sixth normal form, when you work in a mainstream database management system and you use optimal normal form, all your queries will require huge joins that will drain the performance of your database and give you those null values back. So again, I don't really see the benefit. Now, like I said, optimal normal form has two different interpretations. One interpretation is a table for each elementary fact type. The other interpretation is no, you start there, but then you also combine those elementary fact types that have the same key. So I've returned to the example we showed before. And now, looking at this collection of tables, or elementary fact types, whatever you want to call it, we notice that two of them have the same key on the session column. That's interesting, because now, in this second interpretation of optimal normal form, those tables can be combined into one single table with that same key, and then the presenter column and the room column in the same table. And this new table now replaces the old two tables, and then with this interpretation, for the same universe of discourse, the optimal normal form would be two tables. As far as I can see, but again, I am not an academic and there is no academic foundation that I know of, so I am not 100% sure, but as far as I can see, this interpretation of optimal normal form is just a different name for fifth normal form. So, why use a different name for the same normal form? Sales pitch, it sounds better. Optimal sounds good. Frankly, I don't know. Anyway, we have optimal normal form that doesn't have a formal definition. And it has two interpretations. One is to have one table for each elementary fact type, which basically gives you sixth normal form, with exceptions where there are composite alternate keys and composite foreign keys. And then the other interpretation is to combine elementary fact types with the same key and then create one table for each combined fact type, which effectively gives us fifth normal form, but because we started from fact types, we call it optimal normal form. Basically, this puts optimal normal form for both interpretations kind of in between fifth normal form and sixth normal form. One foundation interpretation is fifth normal form, the other is halfway between fifth and sixth. But again, there is no academic foundation, there is no research, so this is my interpretation, and I might be wrong. I don't think I am, but I cannot give any guarantees. That finishes the coverage of optimal normal form. We still have one normal form left to go in this series, and that is domain key normal form. If all goes well, then that video will be live on YouTube in February 2025. Of course, as always, for those who can't wait, for those who want more, for those who like a different approach, check out my Pluralsight course, 7.5 hours of in-depth coverage, and the link is on the screen, and I will also put the link in the comments below, in the description below, I meant. That's it. I thank you once more for your attention. As always, please like, subscribe and comment, and as always, thanks for being here. My name is Hugo Cornelis. Goodbye.